has read the paper on decentralized society? Can you raise your hand? Or, okay, who's read just part of it, first 10 pages? Yeah, okay. All right. And who, if you're familiar with quadratic funding and voting, can you also raise your hand and the mechanism? Okay, wonderful. And then who's a scientist or has been a researcher, worked in a lab? Okay, great, fairly sophisticated audience. So in this presentation, just a qualification, all these thoughts are my own, not of my esteemed co-authors, nor of my esteemed employer, Flashbots. But let's get started. So I want to talk a little bit about the animating principles behind decentralized society, and in particular, some philosophers and economists that really provided the ground principles, starting with Hayek and Elinor Ostrom, who you might know her work on public commons, as well as Michael Polanyi, a philosopher of science. Can you raise your hand if you've heard of Polanyi before? Okay, cool. So this is like a 30,000 foot overview of decentralized society. So we will dig into this more, but the basic idea is that we look at coordination units. That's okay. That's good. It's sort of staying. We look at coordination units starting with the individual and drawing on the principle of local knowledge from Hayek, that those closest to a problem usually have the most knowledge. And then we build on that to discuss communities, and drawing on the principle from Elinor Ostrom that those closest to the problem generally have a greatest stake in the resolution of the problem. And then we introduce this principle in DeSoc called consensus or cooperation across difference. And the principle behind that is that consensus by the most diverse stakeholders is key for local units to compose into broader networks of coordination to produce plural goods or public goods. Like that was all a big mouthful. We're going to dig into that deeper, but I just wanted to give you a sort of overview of the principles. And I also want to take a pause and think a little bit about Michael Polanyi. So as I was thinking about this talk, he's kind of kept coming back to my memory. I read him about 15 years ago. And he's this wonderful philosopher of science. And a lot of the intuitions he had about science, about scientists, scientific communities, and scientific networks kind of map onto the principles of decentralized society. So he talked a lot about tacit knowledge and scientists almost as being kind of an entrepreneur. There's a lot of intuition, risk-taking, personal commitment involved. It's almost even an art where the methods can't really be explicitly formulated but are transmitted like from master to apprentice. He talked a lot about communities of scientists and how mutual authority should exist between them, not above them, as well as broader networks of coordination by mutual adjustment of scientific initiatives where scientists form overlapping competencies and neighborhoods and networks of mutual appreciation. So I really liked Polanyi as I was thinking through this presentation, and it kind of, another observation that he made was how science in a lot of ways like markets, like from the outside, it looks like adrift, irresponsible, selfish, and chaotic, right? But just as markets have this sort of mutual adjustment in prices, in science, right? Scientists have this mutual adjustment by virtue of, published papers. And one of the things that Polanyi, though, left unanswered for me, and is something that I want to dig into today on decentralized science, is like, what actually is the intersection of markets and science? Who pays for science? Yeah?
Answer the question, can I just talk to you?
Sure.
So your laptop only supports one screen. If you want two screens, you can use mine.
Oh no, it's okay. It's fine. I think is one screen fine for everybody? It's just for legibility. Okay, great. It's fine. Thank you so much. So a big question that Polanyi left unanswered was like, who actually pays for science, right? And what is the relationship between markets and science and the production of scientific knowledge? Are these separate design spaces, and how do we build, better scientific networks? And so when I read this 15 years ago, I was like, this is great, all the analogies between markets and science, but like, how does this actually all, come together? So this is something that I want to explore in this paper, but excuse me, in this talk. So the paper's 39 pages, and this is 39 slides. So they're kind of like similar, right? So anyways, In the paper, we talk about a stairway to dSoc. And similarly, I want to do a stairway to dSci here, starting with the unit of the individual scientists building onto scientific communities and going on to discuss how scientific networks are made. So, and we're going to do this in 3 parts, by the way. And in each part, we're going to stop, pause, and I want to let everybody ask their questions, and then we can build and move forward. So this is a combination of a talk and also a workshop. And by the way, please ask any question. Like, no question is a dumb question here. It's really important for me that these ideas get battle tested. So starting with the scientist, how do scientists establish their reputation? We've talked a lot, I've heard a lot of talks. Isabel was making some really fantastic points about this earlier. And as we all know, scientists in academia have to publish or perish. And how do they do that? They essentially trade their free labor and their research for publication in a prestigious journal like Nature in exchange for status, right? And how does this prestigious journal have its own prestige? Well, they also get peer reviewers to contribute their free labor as well. And they do that also for status, right? And how do universities fit into this sort of knowledge production ecosystem? Well, they actually subsidize a lot of the research, and then they end up paying to see the article, right, that they subsidize. So they pay at both ends, right? And then taxpayers as well, right? We subsidize universities, right? And then for research that stays behind a paywall, right? So like in this knowledge production ecosystem, like what are journals doing? Well, they're essentially rent extracting zero-sum status Schelling points. In my humble opinion, right? And like the researchers are unpaid, the peer reviewers are unpaid, the labs and universities end up poor, science and research stays closed. And also it kind of creates this like oligopoly of like scientific knowledge, production of scientific knowledge. Only those wealthy universities that can afford to pay for the research, right, get access to those articles, right, to build off of that, while lesser endowed universities end up with less access. And we see this kind of like oligopoly and inequality in the production of scientific knowledge, and a kind of Matthew effect there. And we see this in the statistics, right? If you actually look at the percentage of papers published by the top 5 major publishers, it went from around 10% to around 70% from 1970 to 2015 in social sciences and humanities. Same sort of trajectory in the natural and medical sciences. And of course, because the marginal cost of actually producing a journal or an article is almost zero, we see the same trend in profit margins. So how can dSoc help here? Well, the first thing that we do in our paper is we talk about decentralizing reputation, and that can be applied here. So the primitive that we introduce is this primitive called soul-bound tokens. And what are soul-bound tokens? They are non-transferable, revocable by the issuer, initially public tokens. Now, there's a lot of question marks about publicity, but I actually think in the context of science, publicity makes a lot of sense because it is such a public status-oriented endeavor. So I think it's a fair assumption to make publicity in the case of scientific research. So what happens? Who issues these tokens? The idea is that universities, labs, and societies would issue these tokens to represent memberships, credentials, qualifications, and affiliations, right? And so if you're a scientist, if you went to Stanford and Columbia, you worked at the Broad Institute, the Royal Society of Medicine, you'd have tokens representing that, right? And if a bunch of scientists did this and a bunch of universities and memberships did this, what we would suddenly see is this scientific social graph or network. Now, I've noticed that throughout this conference, a lot of people have been talking about how do we create a knowledge graph? How do we create this social network graph? Well, this is actually a very easy and decentralized way to do it by having the institutions, right, issue these credentials, memberships, and affiliation tokens, right? And in this, you kind of start to see the beginning of what Polanyi talked about, of these like chains and networks of overlapping scientific expertise and intersections of science. So okay, going back to this issue of journals, like how does this help us in the journal status, zero-sum status Schelling point problem, right? Rent extracting Schelling problem. Well, you can imagine like universities just forking over just a fraction of their funding that goes to journals. Now just in 2015, journals, I think the annual revenue was something around $9 billion, right? So just like a fraction, like even 1% of that is like what, like 90 million? A fraction of that, putting it towards a research DAO, step 1, right? Step 2, having the research DAO offer to pay researchers in the form of prizes money to publish their research. Also, that research DAO paying peer reviewers to essentially become peer awarders, right, over research papers. And we can bootstrap off of the network represented by soul-bound tokens, and essentially also see who are the peer reviewers and researchers and awarders who previously published, right, in journals, because those can also be represented as soul-bound tokens. And so essentially this enables us to fork away from that model, right? And the end result is that the DAO publishes research to the world. And we move from a system of closed science to open science. So just sort of to recap, like, who are the winners here? Researchers and peer reviewers get paid it. Universities end up with like more cash, right? Science goes from closed to being open, right? And the sort of production of scientific knowledge goes from being monopolistic to competitive. So I want to pause here and let anybody ask any questions before we move on to the next phase, talking about how we can build better scientific communities and build on this. Go ahead.
Is there any like strong vested interest with these journals that are like very entrenched, that move beyond, like this seems completely logical, right? But I'm wondering if there's like any like strong push against this from...
Oh yeah, the journals will absolutely lose. So like they are the loser in this game. So they have zero incentive to actually issue soul-bound tokens that would represent your prior publications in journals, which is why you would want to bootstrap the network based off of credentials, memberships, and affiliations, and actually have this sort of network pre-existing that can kind of on its own police and issue tokens to represent, say, okay, this person in this lab at Stanford actually published this paper in journal, and not this person with the same name at MIT, for example, right? And so there's a couple of different ways we can think about how to bootstrap actually representing the journal soul-bound tokens, but that's just like a very simple mechanism, and I think one that would be relatively easy to get off the ground.
Yeah, this is awesome. I have a little bit of a concern with the bootstrapping in that to some extent you're importing inequalities and power dynamics from the old system into the new system. So how do you see that dynamic playing out?
Yeah, so we can talk about that in the next section when we talk about funding scientific communities and creating novel communities. Yeah,
Awesome.
I'll just footnote that.
Okay.
Shall I move on? Okay, you, sir.
How do you see like the role of different motivations? So you said like researchers are paid and peer reviewers paid, but like I think there's like in research like a lot of other motivations that we also have, and like sometimes they are called out by monetary incentives.
Correct. Correct. So I see, and that's an excellent point, and that's a point I want to get to, towards the end of this presentation when I go back to the question of who pays for science and the incentives, around scientific knowledge production. And hopefully in this presentation you'll see how this is actually a bottom-up, peer-to-peer scientific way to fund research rather than a top-down directed form of research, right?
Do you think it's possible to see the system with just like one institution, or do you think it requires a lot of institutional buy-in simultaneously to get?
Well, I think universities, right? Universities pay, like there was a big fiasco, I don't know, in the past 10 years, people in this audience probably understand it better than I do, right? With like Harvard almost like stopped paying some of these publications because they were like, look, you are just rent extracting from us. So universities have the greatest interest to do this. And they actually, like most of these credentials also come from universities anyway, right? So I think you would need more, to answer your question, I think you would need a broad-based set of university to participate, but they also are highly incented to do when $9 billion a year goes to rent extraction.
Isn't it even possible to just completely bootstrap in the sense that, for example, like an academic email is already like a thing that you could use to whatever, like mint a like soul-bound token, like if you have like a specific like Harvard.edu email, like it already is like enough credential without Harvard having to give you like a soul-bound token, right? Like you could probably like bootstrap cleverly without even asking them for buy-in, like as a scientist to basically claim all your affiliations even without asking.
Yeah, so the one issue is that you would want it to be like revocable. So like you might work in a lab for some point and then leave that lab and go to another, to another lab. And so that token should represent like your time there and just like not exist forever, which is something that certain kinds of credentials don't capture well. So I think the revocability is actually important. Go ahead, Tyler.
Do you think it has to be issued by the institution? Does the soulbound token representing your, let's say, attendance at that, does it have to be?
I don't think it has to be, but again, I think it's like,
factual, right? Independent of whether or not the university issued. I mean, you could factually prove that somebody.
but how do you prove it? You prove it by like going to the registrar's database, right, and like showing your diploma. Like how do these things actually end up defaulting to proving some kind of piece of paper that's given by the institution? I actually don't think it's a bad thing, right? Decentralized society doesn't mean like everybody just gets to claim whatever credentials they want. It's like when you earn a credential from some party, they can like give it to you, right? And again, I think everybody's highly incentivized to do this here, right? Like maximally incentivized. All right, so I'm going to move on and talk a little bit about communities now, how just to stay on schedule here. So how can, and this is kind of like drawing on the work of Eleanor Ostrom, who did a lot of work thinking about public commons, how can soulbound tokens actually make better scientific communities? Something that I've also heard a lot in this conference is this discussion about the reproducibility crisis. So one thing that we can imagine doing these research DAOs doing is actually adding on this like secondary function of peer reproduction to the peer review process. How do soulbound tokens do this? Well, they don't just represent memberships, affiliations, and credentials. They can also represent certifications, right, and permission access to certain qualified labs. So if I'm a researcher and I write a paper and there's a certain set of experimental conditions under which my paper was done, I can tag that paper with soulbound tokens, right, that represent, say, the kind of labs, and even represent like the validated kind of equipment that I used, right? And then DAOs could go ahead and contract those experiments across a randomized set of those credentialed labs, or say researchers who have those credentials to perform those experiments, right? And then suddenly, on top of peer review, we also get peer reproduction, and the scientific research becomes much more, right, useful and valuable in information. And then we get this, tertiary property, which is really interesting, which is traceability in experiments. And this is something that's like really important, right, in the production of scientific knowledge. We want to know not just like, who requested the experiment, who conducted, but like where it was done, lab provenance. And in the paper, we talk a lot about social provenance, but I think the same thing can apply here. The same principles of having lab provenance, knowing sort of the origins as represented by the SBTs of the experiment. And so if you want to like throw this on a blockchain too, right? Like, so blockchain inclusion would tell you like the time, right? Or like when the experiment was conducted, like who commissioned it or who paid for it, right? Who the experimenters were, and like SBTs would give you lab provenance. So then we get a kind of very full picture about where this knowledge is actually coming from, the what, when, who, and where.
I have a quick question. Is the credentialing of these labs done via universities, or who?
So you could have like independent credentialing organizations, right? So there's certain like biohazard level labs, right? And there's independent credential organizations that go around to determine, okay, you're level 6, level 7, right? Even the FDA could issue a credential here, right?
I think one other work, I actually used to work on this project in 2012 called Predictive, which was the meta like information layer responsible for attribution for online content, for like who helped create something, not so there was this meta layer, and there was a people could tag certain content with a Chrome extension, and then other people could see it, and then there was a resolution and commentary resolution, and certain tags were verified and certain weren't. So like people could say like, oh, I contributed to this part of this paper, but then then there would be a verification, and enough people would have to confirm that that indeed happened for that to happen. So it's possible to do it also in decentralized.
Yeah. So right, and so this is kind of like that's the same logic behind bootstrapping soulbound tokens that represent prior publications in journals, right? You're going to have to bootstrap off of the existing network of scientists to say, okay, like this is actually a legitimate scientist. It's not some person with the same name claiming to have published this journal, right? Article. Moving on to how we can further enrich scientific communities. In the paper, I talk about this shift in DAOs from airdrops, which is just dropping tokens to whoever, whatever wallets use a protocol, to moving to soul drops. I think we can actually extend that in the context of science to lab drops, which is basically funding for science based off of computation over SBTs. So you can imagine, like, if you know, say you wanted a set of experiments done at the intersection of like biology and physics, so like biophysics, you could compute over the SBTs of scientists and draw in, right, that expertise in an intersectional area of science to solve like an intersectional problem. So that's pretty cool. Another application is you could actually create novel incentives. Say you're a government agency and you want to have a set of experiments, but you want data shared around those experiments. You created novel incentives based off of the SBTs of labs and encourage cooperation across those labs. And for example, offering more quadratic matching funds to the more labs that participate in the experiment under the condition that they share information and they collaborate and co-discover. So this unlocks a whole new set of like incentives for collaboration, right? And then furthermore, we could actually, going back to that like, you know, knowledge production, you know, scientific knowledge production supply chain, we could actually even create, you know, further divisions of labor in there and separate out functions of, say, you know, hypothesis makers, experimenters, researchers, reproducers, peer reviewers, and incentivize those individuals by computing over their SBTs to create plural, partially owned shared research rather than research just under one roof. Yes?
SBTs are one tokens, right? Like
correct.
Computation over SBTs, what does it exactly mean?
So it means like, so say I want to find like a, you know, biologists and physicists and I want to put them in one room, right? So I could, you know, go back to sort of the open scientific graph represented you know, by SBTs, souls, wallets holding SBTs, and say, okay, like I'm going to pick these credentials, certain credentials, like say a member of the Society of Physics, member of the Society of Biology, and then that pulls, right, those set of individuals for me, and then I can convene them using, say, quadratic funding or matching, something like that, to pursue, you know, scientific endeavors and encourage them to cooperate by giving them more funding, the more of them participate, right, across diverse labs. Does that make sense?
Yeah. Will that incentivize like over participation? So like, you know, that people will be like incentivized to like spread themselves really thin across, so they gain a bunch of those tokens to be, if he's at least saying focus on something that's more narrow.
Well, I don't think, in the case of soul-bound tokens that represent your scientific like affiliations or credentials, like that's like hard work. Like it's not something you can easily game. Like you can't go like to an NFT farm and like get like a Stanford soul-bound token, right? So, but in terms of like, say, I think what you're asking is like, would scientists be distracted by all this new funding? I think that's a problem that is a good problem, not a bad problem. But we can talk a little bit more about later about incentives around maybe over-coordination and collusion, which you might be getting at. Go ahead.
Just, what level of like granularity of credential do you imagine SBTs representing? I mean, is it from all the way to the top like level of institution, all the way down to like performed this experiment in this paper that was published? I mean, is it the sort of thing where you imagine people having libraries of thousands, tens of thousands, potentially of soul-bound tokens associated with it?
I actually don't know where the equilibrium will end up. I can't say. I mean, I think the granularity will go as deep, say I'm a first-year grad student versus a fifth-year grad student versus a PhD, right? Like I think that but these things are revoked over time, right?
Yeah.
As well. So I don't see it as like a static, you know, you accumulate an SBT and then it like sticks with you for life. Like it's a dynamic representation of, right, your identity in the same way your LinkedIn profile or CV changes over time, yeah. Right? The constellation of SBTs that signify your credentials and affiliations will also change.
Yeah.
Go ahead.
How are you thinking about the credentialing of the credential issuers? So, like, because obviously there are tons of institutions that can be offering these, and
right.
you want to make sure that
right.
they are verified and not just like fraudulent issuers.
Right. So I think, and then this is kind of why I like science as a starting point. I think that's like a real problem if we were to just go to like hyper-financialized DeFi, right? Where it's like half of it's overrun by bots and the communication channels are just thin and you're just like, you know, being brain fracked by financialized bots for information, right? The nice thing about science is that the communication channels are actually very thick. Scientists are very, right, covetous of their credentials and their status, and they sort of self-police. So I think this actually might be the community that has the right properties to self-police. And in this sense, right? Like it's not just, so your question is like somebody fakes, being Stanford issuing these credentials. Like I think in this sense, individuals and communities emerge as emergent properties of each other, right? And if they're actual scientists at Stanford, they're like, this is a fake credentialer, right? That can be like called out. And yeah, go ahead.
Yeah, I mean, there are certain things, there's like empirical credentials, right? And then there are things that are like, there's some level of subjectivity involved. And I think on those things, it's probably interesting to explore like consensus mechanisms, or more like what you were saying, Ella, like more decentralized approaches for having groups of people decide when somebody is issued a sort of token. Again, this is like probably getting into a pretty level of detail that's unnecessary.
No, it's actually a really important point, and that's something I think that is kind of in the, I hope to discuss a little bit more, but like going forward, but you have to bootstrap off of something, right?
Yeah. Totally.
So we'll get there, right? All right, so the other thing that soul-bound tokens allow us to do is they allow us to, right, science doesn't just happen in a vacuum, it happens with subjects, right? There's researchers and subjects, and it allows us to align incentives to, encourage those who have the greatest stake in, say, research, for example, cancer research, right, to participate as data subjects. But, I know that Ocean Protocol has thought a lot about this, so I would love to hear your thoughts on this, Trent. But one thing that SBTs could also do is not just bringing these different parties together, right? They could also empower data creators, say like a subset of women who have a certain like breast cancer gene, right, or have a certain disease states, to form data cooperatives together to negotiate or the residual rights over their data, right? The rights to use, consume, destroy, and profit, perhaps instantiating their own rights to bargain for, intellectual property born out of research. So this is super cool, right? This unlocks economic incentives, right? Not just for scientists, but also, research subjects to maybe even, right, form novel data cooperatives that like show scientists novel data and like sort of tease them, be like, hey, have you thought of this, right? So it's a very exciting, I'm actually most excited about this aspect of soul-bound tokens. So just to kind of recap, and then we can answer and ask more questions. Like, not only can we move from this sort of, zero-sum status shelling point, but we can also move to research markets that are more cooperative, reproducible, traceable, right, with rights decomposed not just across scientists, but across their subjects in a more positive, some transparent way. So I'll pause before I continue to the next stair of dSci here and let anybody ask any more questions. Go ahead.
More of a comment, but I mean, there's a huge number of things that come to my mind immediately when I'm thinking about this in the context of like an on-chain intellectual property system as well. Like I would imagine if you had, and a lot of the thinking that we're doing similarly at Molecule, like basically trying to look at what would the next version of an intellectual property system, revenue distribution, data sharing actually look like in the context of something that was fully on-chain and fully mediated that way. I think the biggest challenge is with a lot of these things, particularly from the perspective of, it's like you need so much adoption, and it's almost like the way that this really functions well and could actually, I would say, win against the current system is by trying to figure out how, like, what is the onboarding strategy to get everyone actually using this, right? Like, whether it's an intellectual property system, whether it's issuing credentials from universities, I think the biggest challenge is always going to be, what does the actual go-to-market strategy in essence look like for this, which I realize is very far away from where.
Well, no, I actually, no, that's a good point, but I am intentional in the order of operations here, totally, right? So step one, right, $9 billion sitting on the table of journal revenue, 100%. Fork it, right? Right. Step two, right, like let's start thinking about peer reproduction, right, and then create a market around data. Right, that's actually the first step towards a market in data. And then step three, right, let's start creative incentives. And I'll talk a little bit this more on the who pays for science aspect. Incentives for data creators to, form data cooperatives and come together, in a kind of collective bargaining arrangement. Yeah?
I think it's interesting because there are like a lot of, I think, bootstrapping MVPs you can do, and that already done, like also like on stuff like the Gitcoin Silotex or stuff like where you think don't need to start with the most radical thing like Stanford issuing soul-bound tokens, but you could literally start with like, I claim to have been to Stanford, it's unverified, and then like a lot of people
paying for science. And so I want to talk a little bit about the spectrum of scientific funding today, right? We have the spectrum of, government funded, public funded university science, right? And that is susceptible, and we've talked a lot about this throughout the conference, politicization, regulatory capture, even underfunding on like specific timescales, right? And then we have, right, more private funding, which is, in-house R&D departments of corporations, right? Venture capital funding, and like, there's an emergence of, we have to look at the dystopia here. I'm going to call it dog token science, but like, let's not to be pejorative over, the current audience, but this is sort of like just extrapolating a little bit to the future. And right, privately funded science also has its own drawbacks, right? It's susceptible to rent extraction, usually to the patent life, right? And if it's not, patentable, then they're trade secrets and it becomes closed, right? And then there's a certain time horizon, right? Venture funds are like 8 to 10 years. You got to have a return, and so, neither of these extremes are like perfect. And so, and more so, they don't really scale beyond the narrow interests of the funders, right? Nor do they really harness the knowledge among the scientists, right? And the mutual appreciation between scientists. So how can dSoc help? Well, one mechanism is encouraging bottom-up funding, basically empowering scientists to fund other scientists through quadratic funding or quadratic voting. And I'll talk about the quadratic funding example first. That's a little bit more intuitive. And since everybody here is very familiar with it, I'll move quickly through it. So step one is you would create matching pools for scientific funding. And we can bracket where those matching pools from, but you can imagine the $9 billion sitting on the table from rent extracting journals is quite a big matching pool just sitting on the table, right? So step one is create matching pools for scientific funding. Step two is scientists donate to other scientists' labs or research projects, even small amounts like $1 to $10, right? And then those donations are quadratically matched, right? But discounted by correlation scores. So this is a key kind of concept of the paper. I'll go into it a little bit more deeply. What is quadratic matching? Quadratic matching means, if 10 people donate $1 to a project and the matching pool is $100, right, that project will get matched $100. But if one person were to donate the same amount of $10, right, it wouldn't be matched at all. So what you're essentially doing is you're rewarding cooperation, you're rewarding consensus, right? But at the same time, we need to introduce correlation scores because the physicists, right, down the hall are going to look at this mechanism and say, hey, if we each just donate $1, we can swamp the mechanism, right, and over-coordinate, and the poor biologists who don't really understand how the mechanism works or something, right, they get swamped out, and just because they had lower participation rates. So what you want to do is actually look at the shared memberships of who's donating to a particular project and discount based off of the shared memberships to correct for, say, majoritarian influence or accidental over-coordination or even intentional collusion. Let me just pause there and make sure the correlation discounts make sense. Go ahead.
I was going to ask, how do you weight correlation? You could have like correlation of, we're both at Stanford, but I'm a biologist, you're a physicist, but we're still collegiate.
Right. So this is like, so in the paper, in the appendix, raise your hand if you read the appendix. Yeah, right. So in the appendix, we introduced just 3 starting points for different correlation. Like correlation itself is like a science unto itself, right? And there's going to be a lot of experimentation around that. You could put like shared memberships under the same square root, right? You can do pairwise. And then there's also this is an area of research, which we probably want to quadratically fund, right? This is an area of research we want to explore. Also, even it's not even 2 people from the same institution. There's also nested tokens, right? If I'm from, a certain zip code, that implies I'm from a certain city, from a certain state, in a certain country. How, all these tokens are not weighted equally, right? So this is something that we definitely need to explore. But the basic idea is there, that basically you don't want to just have quadratic funding. You want to correct for over-coordination and account for the memberships and affiliations that can swamp the mechanism. And so what is the actual intuition behind this? So let's go just a little bit deeper. The the intuition is that, you know, there is this latent tacit knowledge, going back to Polanyi, this concept of tacit knowledge among scientific networks about worthwhile scientific pursuits, right? Step one. And then step two is that consensus between the most differently affiliated scientists, the most diverse scientists, is a better signal of novel, you know, worthy scientific pursuits than, say, consensus between similarly affiliated scientists who are more likely to over-coordinate or collude for narrower scientific pursuits. So basically, to like, let me restate that. Another way to put it is that, you know, the more diverse scientists agree on an area of research, right, from like, you know, just different fields, the more likely it might be a promising breakthrough bridged across disciplines. Now, we can play with this mechanism as well, not just around like, you know, correlation. We can also say, okay, well, maybe, and over time, experiments will show what is actually generating more and breakthroughs. We can experiment and say, well, maybe like actually like intersectional scientists tend to have like better predictive power, and we can modify and tinker with it. But generally, the idea is that you want to capture consensus across differences, not consensus amongst like a highly concentrated group that is at the center of a field. Trent, you had a question? Okay. So like, back to this question though, who pays, right? Who pays for the matching pools of quadratic funding to let scientists fund other scientists, right? Well, and I'm sure like this was just like a quick Google search. I'm sure Tyler, you know this much better than I do, but like the NSF and, you know, NIH alone have like a $40 billion annual budget. That's not including like, you know, DOD or DOE or all these other forms of, you know, subsidies. Private philanthropy, just for giving to health organizations is like around the same amount, $40 billion. And that's just the total annual giving. By the way, these are US numbers, US, and that's just because I'm American. You know, the total US annual giving is $450 billion. So maybe that could actually increase over time as we encourage more participation. And then universities and colleges, you know, they spend about $68 billion on research, or they, at least in 2015. And then of course, again, we have $9 billion from like rent extracting journals just like sitting on the table, right, to like bootstrap these experiments off of. And like, so why am I so excited about matching pools with you know, discounted correlations? Like, I mean, I really do think this could usher in a kind of renaissance in scientific coordination, because it does a couple things that neither like public funding or private funding accomplish, right? It harnesses and essentially open sources the local and tacit knowledge of scientific networks. It also, because scientists are, say, donating or even, say, quadratically voting how to distribute a matching pool, right? It creates incentives for them to sort of co-create and collaborate in a kind of like fund it and help it rather than fund it and forget it model, right? And maybe even to like collaborate further, which, you know, enables, you know, broader cooperation of local scientific units composing into larger networks. And most importantly, I'm excited about this because I think it would birth more intersectional, novel scientific communities, and which would ultimately yield more breakthrough scientific, more scientific breakthroughs. The assumption being that breakthroughs don't happen at the center of the field, right, but happen on the edges, in the kind of intersections and the fuzzy areas and the gray areas. Isabel, you mentioned a researcher at Santa Fe who's done a lot of work on this, like on the science of science. So, you know, I'm sure he would have a lot of thoughts on the sort of mechanisms around this. What's his name again? James? James Evans, yeah. So on my to-do list. So yeah, so I'm super excited about this. Go ahead, Tyler.
No, just an observation more than anything else. So I mean, currently, if you look at the process of like NIH funding, and this is my understanding, but as far as I know, it's ultimately signed off by like an IC committee director, but I think actually the first stage of almost all grant reviews is like a peer review process of a scientist from typically a similar field. I mean, it's actually not super far off from what you're describing here, but I think when you look at like the NIH, for example, what tends to happen is you have people within like at one of 27 institutes that is sort of domain specific, reviewing work that is only relevant to their field. And I think maybe one of the more interesting things here is like actually that intersectionality and sort of differentiation that you would get with a system like this. So something like, it actually probably is a bad idea to have only people that are working within a very niche subdomain reviewing whether or not people who are submitting work within that subdomain should get funding. I'm curious to the extent that this could enable something more cross-sectional, but to implement something like this at NIH is really like the process is more or less already there. It's really just the technology and obviously the regulatory hurdle of getting anything done in a government institute. But yeah, I just wanted to comment on the fact that
right, but
the scientists reviewing and determining whether scientists get funding to a certain extent.
Yeah, it's a scientist determining other science, but at the same time, right, we don't have the, they're doing it within a field, right, they're not, as you said, it's not intersectional, it's not, right, it's not, and that's where I think the scientific breakthroughs are, that's my assumption. Go ahead.
At the NIH, you're not pitching your own research. Some blind advocate is pitching it on your behalf. And if they didn't get enough sleep the night before, and you have enemies on the committee who don't like you, then your grade dies for another 9 months.
Totally.
Right.
And it's hyper-political.
Right, it's politicized, all these other things.
Solves the political aspect?
Well, it does, right? It actually does solve the political, because the correlation scores precisely take into account what your solidarities are. Right, based off of your memberships and affiliations, and there's an experiment, a whole research field that should be born out of this, around that, right? But that's the whole idea of correlation scores, is to depoliticize, right? Depoliticize it. Go ahead, Trent.
And sometimes breakthroughs are at the boundaries between 2 or 3 intersections, 2 or 3 fields. Also, sometimes breakthroughs are within a single field by one super courageous researcher that is going completely against the grain.
Correct.
Right? So how would this handle that?
Well, I mean, it's peer-to-peer scientific funding, right? If scientists think that if there's a consensus, there's a rising superstar with an MIT, right, biophysicist who's like the next Darwin.
So I just wanted to pick up on that because that was actually the intent behind my original question, and I think you made an excellent point about Darwin, and you made an excellent example with Jeremy England. I don't think Jeremy England needs more help than he got, and I'm more worried about all the non-scientists out there that should be scientists. I'm worried about, and by the way, this is not a critique at all. I agree with your point that we need to start somewhere, that we can't solve all problems at once, and I completely agree with the expansion of the design space. I think my point is more that these things are happening within a complex system where the definition of what is success. It takes a long time to materialize. Regardless, it is always subject to future revision. And in the meantime, all we have are these social networks and these bets that are placed on each other. And I think there's a very strong risk unless we design intentionally ways to bring in all this. All these contrarian perspectives and all the people that don't currently have access to the system, that would just perpetuate the groupthink that we have today in the system. Yeah.
Correct. And that's why I think the mechanism can be experimented with, and over time we will see, we should experiment across different matching pools, what correlation kind of discounting, right? We're rewarding cooperation, right? But then we're rewarding cooperation across difference. Maybe we want difference, right, bracket, and understand a little bit more what that means. But this brings me actually to my next point. You're always 2 steps ahead of me, bro. Yeah. So no, but it brings me to my next point, which is that actually it's 2 points ahead if you don't mind. So just to cap this, I think these points on what I think the renaissance of science that this could usher in, this basically I think just puts Polanyi's ideas on steroids, right? We get mutual authority between scientists, it's a network of mutual appreciation, overlapping competencies, more intersectionality, right? More exploration. And now this gets me to my point, right? So are we done yet? I don't think so. I don't think this is just matching pools of quadratic funding with correlation discounts to scientists is the solution. We also need to ask, who does science actually serve? To what ends, right, does science serve? So it's not necessarily the narrow interests of funders. It's also, I wouldn't argue that science should necessarily be done for science sake, right? As this a priori ex ante exercise, right? There's also scientists is science is supposed to help people, right? Help humanity, reduce suffering, right? If you're into Ludwig von Mises or something, right? That's the whole point is minimizing suffering, right? And less pain. And so I think we have another set of stakeholders here who are the beneficiaries of science, people, us, right? And so I actually think that we also need to have a kind of matching quadratic pool with correlation discounts for beneficiaries of science, right? And that introduces a kind of new force, a new pull, right, in the direction of science, so that it is grounded, right, also in the actual needs of people today, right? So in this way, I see dSci as kind of emerging as this third way between, public and private funding, avoiding the weaknesses and shortcomings of, say, politicization and regulatory capture of, top-down, government and university science, also avoiding the sort of the rent extraction and the trade secrets of private science, but yet capturing the market incentives and the strengths of both. So on the public funding side, right, giving matching pools for beneficiaries in their communities to, quadratically allocate with correlation scores. That captures a public mindedness and the, science as a way to alleviate human suffering, and the matching pools for scientists, right, that encourages sort of the expertise and breakthroughs, science for the sake of science, science for truth. And in this tension between the two, right, between this a posteriori, a priori, ex ante, ex post, I think this is where we truly get decentralized science. And my last slide here, in this way, Polanyi talks a lot about, building a society of explorers, right? And we move, from a republic of science to like a society of explorers where, all parties across the spectrum, not just scientists, but also the beneficiaries are maximally incentivized to participate in the production of scientific knowledge. So anyways, I think soulbound tokens are like very useful and cool and could help us, create this society of explorers. Thank you. Go ahead.
Yeah, so I really like the idea of the soulbound tokens. I'm curious what the implementation looks like. Because it seems like it's doing a lot of work in terms of all the sort of metadata one might imagine on some sort of SBT credential, right? And how do you standardize it? How do you make sure that, for example, right now we have papers essentially as SBTs, and that has created a weird shelling point with all these reverse incentives. How do you avoid the standard of SBTs eventually potentially compounding to something? How do you have both dynamism in some ways around the design of it, as well as standardization?
Yeah, so I think this kind of gets to deeper points that we make in the paper, which is actually even decentralization across technological networks, right? Like blockchains, for example, like you can also have they're kind of redundant in a lot of ways. You could have data stores, right, as well. SBTs, really, the most important thing about SBTs are not the name SBTs, but the properties which they reflect. And we talk a lot about in the paper, especially in case, so in this area of science, I think publicity matters because people want to know and have a right to know, especially if we're subsidizing the research. But in other areas, right, privacy, there is some level of privacy and programmable privacy. And in a lot of ways, verifiable credentials can be seen as an extension of SBTs, or SBTs an extension of verifiable credentials, right? And so I think we will have a plethora of, and hopefully, of different kind of tools, DIDs or VCs or SBTs. But really the point here is not the name, but the properties in this initial bootstrap. Did I answer your question? Okay.
This is maybe an unfair question because I think it goes beyond the scope of what we're talking about to a certain extent. So if you look at, and it's maybe also more of a critique of quadratic funding than anything else. But so if you think about some of the most, let's say, important scientific breakthrough, and this has been discussed several times at the conference now, but so many things were a function of serendipity and also not objectively trying to do science that was going to be in any way helpful to people or that was motivated by doing good. In fact, a lot of major discoveries were just a function of complete curiosity or coincidence. Like the discovery of graphene was like a postdoc basically accidentally shaving off a thin layer of carbon near some tape. But for things like, there was an entire class of antibiotics discovered on the health of a pygmy sloth on this island. And I think if somebody put up in a matching pool or on Gitcoin, I want to go study the pygmy sloth in this island or whatever, there would be a lot of people that would be like, so fucking unnecessary in the context of all the things that we have to focus on for humanity right now. We have to focus on medicines and climate and all these things, but there was like an entire class of like antibiotics that came out of somebody doing that sort of work. How do we account for that, or how do we enable some level of serendipity to occur? One of the things that I was having a conversation about over dinner the other day was just this idea that, like, in my mind, and again, this is like hyper idealistic, probably will never happen, but it would just be to like figure out ways to give smart, curious people resources to do like whatever they want, actually independent of whether or not it was important for humanity. Like, I think a lot of the best science is probably driven purely by curiosity, and somebody almost having like a play-like relationship with discovery. It's something that I feel when we think about effective altruism, when we think about all the quadratic funding, I think a little bit when we think about how that intersects science, we actually lose a lot of like the discovery, play, curiosity.
Randomness and serendipity, right?
Yeah, totally.
So here's my response. So this is a model not to, right, this is expanding the possibility space. It's not like the solution, like where I'm actually very aligned with you in the sense, like there is anything that's like proposed as a solution, right, to all like, it's like, no, man, it's not how it works, right? So like it's, there's always, technology and technological innovation never stops. And every paradigm, even this paradigm, has its own dystopia, right? But I would say what we do here is, so like right now we have this sort of top funded, I mean, like even tokenized NFTs, intellectual property, these are top funded these are top funded models, and at least we're opening the possibility space to have more bottom up funding mechanisms through scientists judging other scientists and like just people, right? And so maybe there is a subset of random people that really are interested in, maybe the island of so-and-so, island of Vanuatu is like interested in like this particular area of research. So it's not the end all be all. It's just we're just expanding the possibility space. Yeah. Go ahead.
Yeah, just to add to that, I mean, if there's a top-down structure which we have at the moment, also scientists interacting up to the top. So research questions is often a place where certain research questions and topics are funded and certain other ones aren't. So it's not just that the top decides that, but the bottom also decides, okay, well, I recognize that this question is relevant at the moment, so I'm going to be doing that research. But as soon as you have kind of more stakeholders, let's say, that are decentralized, you can actually adhere to those rather than just the top. I imagine that does open quite a
research, right? And people maybe just dropping in as individual roles and contributors, but you could also see, right, novel, like, forms of coordination between labs, right, within labs. And I think just these mechanisms, like we can't predict, right, how scientists will choose to fund other scientists, whether it's individuals or labs or, right, or even people, right, choose to fund science. But I think we will see we will see a lot more expansion beyond the existing models that we have today of, from top-down funding, for sure. Go ahead.
Yeah, so really interesting. Something I'm very interested in personally as we're building, a couple of infrastructure for decentralized science. One of the things is that a lot of the value that the journals create is actually through the curation process, right? Surfacing up what is considered, groundbreaking from what is not.
But using the peer reviewers, right?
Using the peer reviewers and the editors. So the way we think about it is essentially it's an ensemble learning process in which the peer reviewer make a prediction on the validity of the work. Right. The editor, then combine these predictions and decides whether or not this will accrue a lot of citations, increase the KPIs of the primary KPI of the journal, which is the impact factor from Clarivate analysis. And there's essentially the self-reinforcing loop in the scientific publishing ecosystem, which is what we call decoupled from replicability, essentially. Now, we're putting too much of a premium on novelty and impact and not enough on durability, reproducibility, and open science, essentially, right? One of my questions in that context is, do you think there's room to applying that same type of mechanism that you have here for allocating funding to curate? Because one of the big, something that could be quite impactful would be to decouple the process of giving feedback as peer reviewers from the process of curating your work, you know, and as making a prediction is where it sits, you know, in that hierarchy. So do you see there's an opportunity
For sure.
to apply that
For sure.
to curation?
For sure, yeah. I mean, I think the kind of monolithic equilibrium journal model that we've ended up with is just sort of accidental, right? Like I think, you know, this idea of research DAOs and like universities forking funding, right, over to them, I think, you know, some research DAOs might have a value add of reproducibility, like I mentioned. Some might have a unique value add of curation, right? And we're going to see a lot of experimentation, or hopefully I would like to see a lot of experimentation on creating like, this is what I sort of mean by plurally, you know, partially shared research, right? These research DAOs effectively creating novel coordinations to produce research that maybe emphasize some aspect, reproducibility or curation or something else, in just ways we can't imagine. I hope that answers your question. Yeah.
Something that's related to reproducibility, but not exactly the same, and I don't think we've talked about it specifically, is establishing better mechanisms for validity. And a lot of it has to do with, well, you know, science supposedly is a search for better ways not to fool ourselves, and yet I think these legacy systems have a lot of loopholes in that built in, as in, you know, the standards by which papers are judged, and the standards, even when you attempt to reproduce reproduction, what is the provenance of all that methodologies that are used, and so on, as well as, you know, everything that's already been talked about of data provenance. So as well, statistical standards and so on is what I'm thinking about. So I think there's a lot of potential for whether it's through the other additions to the quadratic voting algorithm or the governance process on top to harden that piece as well, and avoid a lot what happens today, which is a lot of money ends up going into just things that we've kind of decided that this is the bar, whereas the actual bar, the classic P 0.5 is a great example. There's many cases where it's not appropriate, and in many cases where you know, the right question is not even being asked, and, you know, an entire subfield is asking itself the wrong question. So I think there's a lot of opportunity to influence that as well.
Yeah, I mean, I think so back to this point about, you know, Stanford issuing these credentials, like, I think that's sort of like, you know, point G, and once we have, right, matching pools and scientists funding scientists and novel forms of like funding even like people, right, quadratic, then we're going to see these, we're going to get to, like, Vincent, what you wanted, these sort of like peer-to-peer networks of scientists that are sort of self-funded, that maybe operate, and maybe operate like, you know, the back to the Polanyi analogy of like master-apprentice, right? These alternative models outside of institutionalized science. But I think we need to get there somehow. And so we kind of have to like cross that chasm, right? Rather than trying to like jump and then like ending up with dog token science, right? Yes?
So to some extent, like I'm convinced that we need something like that, and also like some kind of a basis for like a lot of people like to experiment with like different funding mechanisms, etc. So to some extent, like my question would be like, what do you actually see as like the concrete next step that should be taken? Is it like developing kind of like the underlying technical stuff that we use then to experiment with funding mechanisms, or
I think the concrete next step is like, let's get some soul-bound tokens with scientists. Let's have them represent their CVs, right? With soul-bound tokens, and then fork the journals. That's $9 billion of capital, right, that can be allocated in a decentralized peer-to-peer way between scientists and also from people to scientists. And like, that is what I see as the next step. Like, somebody needs to go fork the journals. It's $9 billion. Like, there is your funding mechanism. Like, and I'm an entrepreneur, so just by way of background, you know, I actually was a healthcare entrepreneur of women's healthcare, started a women's healthcare company. Like, so like, as an entrepreneur, that's how I think. I'm like, where is money sitting on the table? There it is, right? Go ahead.
one like small step that I see, even with like organizations like DAO, it's just like funding small MVPs, like they're doing like a tiny GitCon round on funding research, doing a tiny fellowship or a tiny prize, because like even if it's like whatever, just $500,000, you see what really also doesn't work before you like scale up with 9 billion.
Well, you're not going to scale like, so you're going to start with like a fraction, right? Exactly. Convince universities, like even 1% is like 90 million, right? So even, right? That's like 1%. So it's like you could even do less than 1% because nobody's getting paid, right?
What like my mindset is, like what I try to do with leaders is to just like be a guinea pig of all of these ideas and try it with 100K and see what works. Then if it works, people give it a million. But like ultimately to I think that's the power also in crypto is to just do it basically with, like in the tiniest MVP fashion. Because I think like all of those ideas you could build this week and run like a small MVP on it basically. I think that's like the mindset, like some of like great these ideas like never get to the point of like getting 1% of the journal budgets. But if they would have a like promising MVP, I think like and then like in collaboration with the organizations and I
mean what I would do is I would look at like a certain publication in like a specific field, chemistry, biology, or like whatever that's just like very highly prestigious. And if it's like limited to a small network, right, of peer reviewers across specific institutions, right? And like I would start from there. So that's how I would build an MVP before like, you know, going for the jugular on Nature, right? But you want to go for the jugular on Nature.
No, actually, I mean, right now you're talking about approaching incumbents. It seems that often a pattern that's worked in Web3 has been to work with the Web3 natives, right? Like, I mean, what if this is just a tool for flashbots and protocol labs research and OceanDAO grantees, right? Administered through Gitcoin, a subset of Gitcoin or something, right?
The problem is getting funding, right? So you want the money needs to come from somewhere, and so I have like I see money over here, just on the journals. Go ahead. One second, this gentleman over here.
Good question. Could you comment on if there is like a future financialization of SBTs and DeSci, or even hyper-financialization, or like AMM? Would that be good for the space or bad for the space?
Depends what you mean by hyper-financialization. I mean, I see dog token science as hyper-financialization of science in lines with sort of like VCs, not being terribly different, just more distributed. But so this gets into questions on the paper about how would the research DAOs actually be run? Like what prevents the research DAOs that say, fork the revenue from nature? What prevents them from becoming rent extractors, right? And this goes into the mechanisms around that. And again, correlation discounts amongst the members. I think that's what we propose in like DAO governance as a way to, keeping DAO for, as a plural good, a public good to the maximum number of, as broad of a network as possible. If you discount the memberships, then you get, the only consensus that comes through in voting is a consensus amongst the most diverse participants, rather than the consensus of, say, a majoritarian group that is trying to, make the DAO a rent extractor. Yes?
Question. What about situations where you have a very niche community that and so then you have a lot of correlation discounting because the only people who are excited about this problem are someone who's maybe coordinating or on a specific forest. So how do you allow that research to still happen for that community even if you are ultimately discounting their preferences?
So the question is, there's a niche community and everybody's highly correlated in that community. And so they're competing for funds amongst like less correlated communities, right? Yeah, it's an open research question. Like we have to experiment with correlation discounts and see what actually works and like what are the results. There's also a question about like, the system is dynamic over time. In the beginning, few people have SBTs, and then people have more SBTs, and then so the whole game sort of keeps changing, and it's very dynamic, and we don't really know where the equilibrium will end up, and that'll inform how we structure correlation scores. But it's a good question.
I just want to make a suggestion that I think I'm a mathematician and a theoretical physicist, and I'd like to suggest that potentially fields like these might be very good starting points. A, because they're very cheap to fund because they require no data, and B, because they're probably where the feedback loop is most broken because there's no data.
Right.
So, yeah, that's a thought process there.
Well, somebody here in this crowd is going to do it, right?
I hope
Like
so.
somebody's going to do it. And the point is actually, you know, back to this principle, back to our old friend Hayek here, right? It comes down to local knowledge and harnessing. The whole point of dSoc, and for that matter, applying principles to dSci, is to harness the local knowledge of the participants, of the individuals and the communities and the networks. And so we want to harness the local knowledge of scientists, right? We also want to harness the local knowledge of beneficiaries for needs finding. And so somebody here has that local knowledge, like, you know, within their community. Go ahead.
What I'm sometimes worried about, like, even in our context, is that kind of like having this intersection. For example, even dSci, like scientists that are knowledgeable about crypto are probably the scientists that like potentially are the most affluent or like need funding the least, or already like the most plugged into funding sources, being in crypto. So like some of the scientists I would love to see funded like might not even like know about like crypto or like Bitcoin or like about whatever. But then I think it's like this inherent conflict that you like potentially reinforce like this privilege of being even like in as a scientist aware of those new funding sources. It's a bit like,
I mean, there's like a period of growth, and in that, like, yeah, like you're a scientist, you got in early, you're going to get your lab funded early, but that's just right. That's just sort of how change happens. There's early adopters, there's late adopters, but in the end, it's not like, you know, your coming in later is going to disadvantage you in matching pools, right?
Totally. I think my point is kind of one needs to make a conscious effort to onboard the people that are the most disadvantaged, like for example, that are not.
Well, I think scientists are generally, as a class, like disadvantaged, right? Like nobody's getting paid here, right? Like, you know.
It's like as one example is, for example, people at Ivy League universities, whereas people at like universities in like emerging countries that like don't have access to any funding or any credentials.
Yeah.
Where like at Harvard bucks probably like have more marginal value than at Harvard. Like, but most likely even in such a system, the money would land at Harvard versus at the most decent.
Right. So this gets and at the end of our paper we talk about kind of this issue of status, right? And decentralization has to also decentralize status. And so I proposed one way to decentralize reputation, but still you have these like institutional Schelling points. And this kind of gets, and again, this is kind of like A to Z. Like I'm introducing like a point in the middle, like M. And hopefully through these funding mechanisms, right, bottom-up funding mechanisms, we can open a third way that enables, right, as I said, like more peer-to-peer scientific arrangements where status is conferred amongst each other, right, and start addressing, right, the far reaches of the world that don't necessarily have these status Schelling points. Yes?
I like the point that Trent made on, it's a little bit orthogonal here, but like of using the SBTs to do some of the retroactive funding of work where there was a broader collaboration, so like where to do like the impact certificate of like, you know, who contributed how, and like, you know, there's actually some discussion there, and there might be a lot of like labeling of the exact sort of split of the contributions within some. One is, for example, not based on a single paper, when a paper is based on another paper, or where there was an actual like physical labor involved. So using that, I think could help maybe like create some sort of like narrow grants of retroactive funding in a narrow category where people will be highly incentivized to label their work, and there would be some review system on that to get access to that type of funding. So that might be like another entry point of getting it into.
Retroactive funding is also a very powerful mechanism that we could layer in here for sure. I want to get Isabella.
I think this is amazing, and I really feel like when I read the paper, I was like, yes, these SBTs, and particularly things like the correlation scores, is something that's really been missing when I've been playing around with some of these ideas over the last few years. I wonder, so my that takes to this point, that we get us to this point. So I wonder if there's like an intermediary, or maybe it's actually a complementary step here around behaviors that are already happening but are not actively incentivized. So we've touched on peer review, but I think another interesting one is reading as a behavior, which is one of the biggest things that scientists do, but is not currently incentivized. And by reading, what I really mean is curation. I think most of science hinges on two things, status and curation. Journals, their primary and perhaps most important function is the curation mechanism. Most of science, in a way, is curated reading lists. Journals are reading lists. Papers, the references call together huge knowledges around sort of certain ideas and certain points. And even if you look at a lab, a PI curates researchers and people to work within their groups. So I wonder if we can think about behaviors that already exist without incentive mechanisms and focus the incentive mechanisms around people who are really disenfranchised from the current system and have the most to gain, so PhDs, postdocs, and early career researchers. I would love to talk more about this, but I think there's a piece around new forms of curation that perhaps could include journals. Journals can stay as curators should they wish to, but I suspect that they will be outweighed actually by a decentralized curation mechanism. You don't have to get rid of them. You can create a system that first includes them and then overtakes them.
Right. This goes to the.
Talking very quietly. Don't tell the secret. I'm summarizing lots of what's extremely quickly now.
Yeah. No, I hear what you're saying. This kind of goes back to your point earlier, right, around curation. Yeah, that's possible. Look, when I'm thinking about incentivizing folks here, I look at the situation. I'm like, all right, we have this like kind of messed up market for science, right? Nobody's getting paid, right? Like the people who are actually generating the knowledge production aren't getting paid, right? And then like, right, and we've got these like rent extractors, and so I'm just like looking at that as just like one angle, but maybe right, there's other ways to have funding mechanisms that, I think what you're saying is that there's like a rung of the scientific ladder that is like highly exploited, right? And that they are kind of prime, and maybe they should be like, right, empowered in a certain way with incentives. And yeah, that's something we can explore. I'm not sure where the money comes from to do that, but we have to, we definitely should think about that. Yeah, go ahead.
Well, so just on this note, something that like reminded me of was the role structure that the graph protocol has with their different, like they have their indexers, the delegators, and then you have like the developers, and you also have the curators, and all of them have slightly different incentive models that rely upon each other. I think that this could be a really interesting thing if you apply the same sort of structure to like like with like article, yes, like with article curation and with article like organization. Obviously, the graph protocol in this case is like the organization of some graphs and querying like networks, but I think that it still like structurally operates very similar.
Yeah. My only hesitation with so crypto protocols could like do this. The problem is a lot of tokens, right, are speculative, right, and you always sort of have to pay the Pied Piper, right, and so so unless protocols or DAOs actually have correlation discounts in governing the protocol, right, to get consensus among the maximally diverse members to sort of prevent it becoming a rent extractor, then they can kind of just recreate the same institutional problems that we have today. Yes?
You were thinking this is one thing, like I'm excited about, like even on this, like instead of like having like a huge funding pool for a specific idea, like almost to do meta science on some of these ideas by running 100 experiments and actually looking at like the results. Because, for example, I think it could even make sense to potentially like give micro grants to people with the least amount of SOTs and like strong signals in the network. Those might be like the youngest people with like zero access to funding, zero access to, but then once they, then there could be like radical experiments, which might be like counterintuitive, or the contrary even to the core ideas, but enabled by the ideas, kind of like, to almost like try out all these different ideas.
Yeah,
There's
there's plenty of mechanisms, right? Like that we can experiment with, like in the matching pool. Like it doesn't necessarily have to be like, you know, solving for consensus among diversity to, you know, yield intersectionality. Like you can also have a separate matching pool that says, okay, computes over SBTs to kind of find like what looks like to be a very young, promising scientist, right? Who might be like neuroatypical in some ways, but like, you know, under certain conditions probably would yield, right? Like all this stuff can kind of be experimented with. And this is just like one particular model that's a deviation from the standard model, but we can do like, you know, 10 steps away as well. And whatever, the nice thing about this is that it lets us actually, it gives us data to experiment with what is actually generating scientific breakthroughs, what works and what doesn't, which is what I really like. Okay, I think I have one more question and then I have to wrap it up. Yeah? No more questions? Okay, well, wonderful. Thank you, everybody. I appreciate your time.